We have few more problems in this set of problems about finite combinatorics and probability connected to that. So here is the first problem that says, in how many ways you can rearrange word summer? S-U-M-M-E-R. Never mind the meaning, which means you can get like word U-S-E-M-R-E-M, excuse me. Okay, so that would be another way to do that. And the question could be easy if you think about permutations. So for example, permutations, you were having a 6 characters here and you're choosing all of them without, so there's no repetition, so there's a permutation because the order matters and there are no repetitions. So you can say, okay, it's just 6 factorial, 6 chooses 6. That's just 6 factorial, right? The permutation 6 chooses 6 would be 6 on the top, and then on the bottom we have how many you're not choosing. You're not choosing 0 according to the formula, right? This is by convention 1, so you have a 6 factorial only. And if you use a calculator, you can easily find out this is actually 720. So 1 times 2 times 3 times 4 times 5 times 6 is 720. However, there's a little problem here. You have this m here, and it's twice. So you can call one of them first time and one of them second name. So you have, like, say, if you have them with a different color, then you will see there's a difference here. So you can have this one to be red and the other one to be, so this is the red one, and the other one to be blue. Okay? So now you can see you have 2 different characters, right? When you talk about permutations, then, you know, this is one permutation, and this is another permutation. Uh-oh. I have to select a different color. So this is another permutation. It is the same combination of characters, but there are 2 different permutations here. Okay, so you have to be careful here. So every time you have a word, you have the m and n on 2 different places, but it could be the first time here, the second time here, or the first time here, the second time here. Anytime you have that, you can have them in some other places, but anytime you have that, you actually have 2 different permutations. Okay, so it's not 720. It is in how many ways you can rearrange m on 2 different places. Well, 2 chooses 2 in 2 different ways. So you have to divide with 2. So it's 360 different words that you can have. Never mind the meaning, because there's no meaning here, but never mind the meaning. You have 360 different words. Okay, not 720. Okay, now the same problem you can have here with the word Mississippi. And how many ways you can rearrange word Mississippi? Well, since you have 4 S's and 4 I's and 2 P's, those 4 S's could happen on 4 places, but in a different order. So if you're going to be talking about permutations, you have 11 characters. So it's 11 factorial for the permutations. 11 factorial. 11 chooses 11. That's 11 factorial. Okay, use a formula if you don't believe. Now that's 11 chooses 11 permutations, but there are permutations that have those 4 S's on the same places but in a different order. You can call, you know, the first S, the second S, the third S, the fourth S, you can call them with the different colors. You will see that there are different arrangement of those S's. You can have different permutations. Well, it's the same word, because it doesn't matter to you whether S is going to be rearranged in one way or the another way if they're on the same places, right? In how many ways you can rearrange S? 4 of them in 4 different places. 4 chooses 4 permutations, so that's the 4 factorial. Then you have an i's. You can also rearrange 4 different i's on 4 different places in many different ways, in 4 factorial ways, in 24 ways. And then you have 2 p's. You can rearrange these 2 p's in 2 different places in 2 different ways. So actually you have 36,760 different ways to rearrange character in the word Mississippi. I know this is hard. This is not an easy problem. So again, the explanation for this formula is you have 11 chooses 11 different permutations, but you also have 4 different places for the S's. 4 chooses 4 in different ways. You can rearrange it, still the same word. So you have to divide all of those permutations with the how many ways you can get the S's on 4 different places. And then the same thing for the I. There are 4 different I's. You can say it's the same I. Well, if you code them with the colors, you will see they're different if you talk about permutations, right? And then you have 2 chooses 2, which is for 2 different p's. So this is 11 factorial, this is 4 factorial, this is 4 factorial, and this is 2 factorial. That will be explanation for this formula. And we want to think about a little more about it, so you see how that works. Okay, here's another problem about the balls. We had this problem before. We had similar problem before, not this one, but similar problem when we were asking the question in how many ways, what is the probability that if you are going to be choosing the, I think I made a video on that. I probably don't have that written in the lecture, but I made a video about it. In how many, if you have 2 red balls and 1 black balls, in how many ways you can, and how many ways. So what is the probability of getting 1 red and 1 black ball? I had that problem, and we solved that by using the properties of probabilities, right? This problem. I have a hat and box with 3 balls, 2 of them red, 1 black. If we draw 2 balls out of that hat, what is the chance that we should have 1 red and 1 black? Okay, so I said it's going to be, the chance of that is going to be 2 out of 3. And there will also be 1 out of 3 chance that you're going to get both balls red. And we use the properties of probability to calculate that. Okay, this is very easy to answer actually by using counting. Okay, I have to label the balls. So this is going to be the first red, this is going to be the second red, and this is going to be the first black. Okay, now it's easy. Any 2 ball, drawing any 2 ball is the same chance as any other 2 ball. Okay, so in how many ways you can draw 2 balls out of this hat? That's the first question you need to answer. Okay, I'll just count. So these are 3 chooses 2. You can talk about permutation because it might matter to you. If you draw ball after a ball, then you draw this one first and this one second, or this one first and this one second. It's 2 different ways. It doesn't matter really. You can use permutation or combination, but I'm going to use permutations. Okay? One choice. First, second. The other choice. First, second. One more choice. First, second. The other choice. First, second. And one more choice. First, second, and the other choice. First, second. Okay? If you can count, this is 6. 6 different ways to get 2 balls out of this hat. Okay? In how many ways you can get 2 balls out of this hat so that one is red and one is black? All right. One way, first, second. Another way, first, second. One more way, first, second. Another way, first, second. Okay, I have this, one of this arrow I didn't really write nicely, so let me try again. All right. The first one, the second one. So the arrow points to the second one. Right? I would say, well, you can count here. It's 4. So 4 of drawings are gonna end up with one white, one red, one black. So it's 4, and 4 out of 6 is the answer here. And of course, you can reduce this by 2 up and down, and you get the answer that we have at the end here. Alright, somewhere here. Right, this is the answer. So that's our answer, because there's lots of talk here in this lecture. Okay, 2 out of 3. Okay, so this is much easier to answer by using efficient counting than by using properties of probability, which is what is done here. So you can read this. We're using properties of probability, but in this particular case, it's easy to count. That easy to count if you have more balls. So I do have more balls here. All right, 7. 4 of them are red. 3 of them are white. Okay, if I draw 2 balls out of the hat, what is the chance that I'm going to get both of them red? That's the first question. What is the chance that I'm going to have both of them white? The second question. And third question is, what's the chance one of them is going to be red and one of them is going to be white? Now that's not so easy to count. Okay, so the property of probabilities are actually maybe easier way to do that. Okay, but I'm going to do it both ways. So the question A is, both balls are red. I can tell you immediately the answer to that is 2 out of 7. The chance of that is 2 out of 7. Both balls are white. The answer to that is 1 out of 7. I'm gonna just write the answer. So it's 2 times more likely to get both red balls than 2 white balls. You see, this is kind of unexpected, right? Because there are only 3, 4 to 3, so you kind of think, it's kind of close. No, it isn't. Actually, it's 2 times more likely to get 2 red balls than to get 2 white balls. You can experiment with that yourself. And what's the chance you're going to have 1 red and 1 white? That is 4 out of 7. Okay? It's 4 times more likely to get 1 red and 1 black than it is to get 2 whites. And it is 2 times more likely to get 1 white, 1 red than if you get 2 red. And again, this is the answer. I'm not explaining that yet. In a moment, I will. But those are the probabilities, and if you add them all up, this is all that can happen. So it had to be 7 out of 7, and it is. Okay. So how do we get that? So I'm going to answer the C part, and I'm going to leave to you to think about the A and B part. It's not really that hard. Actually, it's very easy to answer the, let's say, the A part. The A part is very easy to answer. Okay. In how many ways you can get 2 balls out of the hat? Well, 7 chooses 2. If the order to you doesn't matter, you're just picking up 2 balls. So you can take 2 balls at once. So then the order won't matter. You would have 7 chooses 2 combinations. And this number is 21. Again, check with your calculator. It's really not that hard to calculate that, but if you use your calculator will tell you. So you have 7 math probability combinations chooses 2, and it's 21. Okay. Now, in how many ways you can get what was that? 2 balls red, 2 balls red, 2 balls red. Well, 2 red out of the set of 4. 2 red out of the set of 4. That would be 4 chooses 2. Also combinations. If you're taking 2 balls, doesn't matter in which order if you're taking it once, right? And this number is 4 chooses 2 is 6. So there are 21 different ways you can get 2 balls. There are 6 of those ways are 2 red balls. So it's 6 divided with 21. So 6 divided with 21 is 2 out of 7, because you can reduce these up and down. You can divide with 3. So if you divide 6 with 3, you get 2. If you divide 21 with 3, you get 7. Okay, that's how. You can also calculate these 2 balls white. What's the difference here? 2 balls white would be 2 out of set of 3. So the change is here. I'm going to have a combination. 3 chooses 2. And that is 6. Oh, excuse me, 3, not 6. In how many ways you can get 2 balls out of the set of 3? Well, this or this, this or this, or this or this. Now, since the order doesn't matter because I'm choosing 2 balls at once, right? So that's the 3 ways, and you got number 3 here. And now, which means that you get here 3 out of 21. 21 different ways to get 2 balls out of the hat, but three of those are with 2 white balls. So it's 3 out of 21. If you reduce up and down, you divide with 3, you get 1 out of 7. 1 out of 7, okay? So that's easy to answer. So I have the answer for this first 2, and then of course the third one must be what is left. I mean, either you have a 2 red or you have a 2 white, or you can have 1 red and 1 white. These are all mutually exclusive. So if the first 2 are 3 out of 7, then the third one is 4 out of 7. Okay, so that's kind of easy answer to do that this way. Okay, I'm going to answer the C. I'm going to answer this one in 3 different ways. I already know it's 4 out of 7, but I'm going to now answer that in 3 different ways. So you see all of the ways you can solve this problem. Okay, I can use the combinations. Combinations, which means I'm drawing 2 balls out of the hat. I don't care which one is first, which is second. Okay, I already said there are 21 different ways to do that. 21 different ways. 7 chooses 2. Now, in how many ways you can get 1 red and 1 white? Okay. Well, there are 3 ways to get 1 white ball, and there are 4 ways to get 1 red ball. So, which means there are 12 different ways to get 1 red and 1 white, or 1 white and 1 red. It doesn't matter in which order, but it's 3 ways to get 1 white ball and 4 ways to get 1 red ball. So by the multiplication principle, there are 12 different ways to get 1 white, 1 red. And again, you can even count that. This one and this one, this one and this one, this one and this one, that's 4. This one and this one, this one and this one, this one and this one, another 4. this one and this one, this one and this one, this one and this one, another, oh, excuse me, 3 and 3, right? This one and this one, this one and this one and this one and this one, that's 3, not 4. This one and this one, this one and this one, this one and this one, 3, that's 6. This one and this one, this one and this one, this one and this one, another 3, 9. This one and this one, this one and this one, this one and this one, another 3, 12. You can even count that. So it's 12 different ways. Okay? So it's 12 out of 21, which is after reducing, dividing up and down with 3, you get 4 out of 7. So that's a way by using combinations. You can use permutations. How do permutation play in the game? Well, if you draw one ball first and one ball after, it should be the same probability of getting one white, one red, right? You're randomly drawing one ball first and then another ball after that, okay? Now, if you do that, you're gonna have permutations for the number of ways to get two balls out of the hat, because now it matters in which order. So the one way is to get this ball first and then this ball second. Another way is to get this ball first and this ball second. So it's more. You have more permutations. But permutation 7 chooses 2 is 42, one way or the other. So that doubles the number of permutations, twice more the number of combinations. Now, in how many ways you can get one white and one red? Okay, you can count. So the first ball to be white and the second ball to be red. That would be 3 ways to get the first ball white and 4 ways to get the second ball red. There will be 12 different ways to get the first ball white and the second red. But now you can reverse that. The first one is red and the second one is white. And there will be also 12 different ways. So then now you have 4 different ways to get the first ball, 4 different ways to get the first ball red, and 3 different ways to get the second ball white. There will be 4 times 3, which is 12. So the total number of ways to get first ball and then second ball of different color is 24. So that makes it 24 out of 42. 24 is with 2 different colors, and 42 is the total number of ways to get 2 different balls. And that, again, if you cancel this, you divide up and down with 6, you get 4 upstairs, and down you divide with 6, you get 7. 4 out of 7. Again, the answer is of course the same, right? So now this depends how you draw. If you draw 2 balls at once, you're talking about combination. If you draw the first ball first and then the second ball second, you're talking about permutation. But the probability to get 2 red is still the same way. 2 out of 7. To get 2 white is still the same way, 1 out of 7. And to get 1 red and 1 white is still the same, 4 out of 7. It's kind of interesting. So you can draw 2 balls at once, and you can do one by one, and the probability doesn't change of getting 2 red or 2 white, or 1 red and 1 white. Okay, you can also answer this by using properties of probability. Okay, so now this is without counting. We just use property of probability. First of all, what does that mean? 1 white and 1 red. That means that you either going to have first red and second white, or you're going to have first white and second red. These are mutually exclusive events, and by the property number 3 of probability, you can calculate the probability of both of them, or one of them happening, is by calculating the first one probability, the second one probability, and add it up. This is probability of either the first red and second white, or the first white and the second red, which means 1 white and 1 red, right? So this event here is actually, at this junction, it's an or between 2 things, either first red or second white, or first white and second red. So which means I calculate this probability first, and then this probability second, and I calculate them, I add them, I got the probability I'm looking for. Okay, so let's calculate the first one. First term, okay? First red and second white. That is by the property 6 of the probability. Probability of the first red time the probability of second white, given that the first one is red. That's the, like, this is the probability of A and B is the probability of, by the sixth property of probability is probability of A times the probability of B given A. Okay? Now it's easy to find this probability. What's the chance the first ball is red? That's easy. There are 4 out of 7 that are red. So it's 4 out of 7. That's the first probability. The second probability, once you have the first red, what's the chance you're going to have a second white? If the first red is out, one of the red is out, you have 3 red left and 3 white left. So it's 3 out of 6 or 1 out of 2 if you like. 3 out of 6. So that's the first probability is 4 out of 7. The second probability is 3 out of 6. You can now cancel here. It's 3 and 3 here. And you can still cancel 4 and what is left here? 2. And you end up with, this is actually if you multiply, it's 12 out of 42. But then you reduce this and you end up with the, you divide up and down with 6 and you end up with 2 out of 7. Okay, I only calculated this probability here. Now I need to calculate the second probability. First white and the second red. What's the chance to get a first white and a second red? I'm going to use the same logic again. First white and second red. Again, this time I have this one as A, this one as B. First white is A, the second red is B. So that is equal to probability of A and B is probability of A times the probability of B given A. Okay? I didn't make a nice B here. Let's try again. All right. So what's the chance to get a first white? Well, 3 out of 7 are white. So the probability of getting the first ball to be white is 3 out of 7. Probability of getting second red once the first one is white. If the first ball is white, then it's out. Like one white ball is out, so you have left 2 and 4 red. So it's 4 out of 6. 4 red out of 6 remaining balls. 4 out of 6. Okay. Now you multiply this. 3 times 4 is 12. 7 times 6 42. You can cancel that again with dividing up and down with 6. Reduce. So you got 2 out of 7. Okay? So you add this 2 out of 7 and 2 out of 7, or if you like, you add 12 out of 42. That'd be in 12 out of 42. That'd be 24 out of 42. I'm adding these two probabilities, this one and this one. So I'm having now 4 out of 7 for one white and one red. Okay? So I'm using here properties of probability. I got the same answer I had by using either combinations, drawing 2 balls at once, or by using permutation, drawing 1 by 1, or by using properties of probability, the same answer, 4 out of 7. Approximately 57%. Now you can play this game with your friends. I mean, you can say, okay, I'm gonna bet on, I'm gonna have 2 different colors, and you can bet that you're gonna have 2 of the same color. And they might think about, it's a fair game. It isn't, because our chance that you're gonna have 2 different colors, 57%. So you have a winning probability, more than 50%, right? And it's 57%, so it's very hard to notice that it's a winning probability. So your friend's gonna say, oh, you got lucky, right? You know, it's not luck. You have 57%, which is more than 50%, so you have winning probability. If you're playing the long run, of course, the first might happen your friend wins, the second might happen your friend wins, but in a long run you will be winning 57% of the time. So you play this 100 times, you should expect to have the winning close to 57%, 57 times. So you're gonna win 14 times more than your friend. He will win 43 times. Okay, well, there are probabilities associated with that, and we're going to study that in the last lecture on the probability, which is going to be about binomial random variables. So we're not yet done with this stuff, okay? But this shows you how to use a probability or counting to calculate how to use the probability properties or counting to solve the same problem. Again, so we just answer here. Both balls red, the chance of that is, I didn't use a probability property for that, I just used for C. But you can do the same thing for A, you can think of that. Both balls red is 2 out of 7. Both balls being white is 1 out of 7. And 1 red and 1 white is 4 out of 7. Again, it won't matter, we just calculated it. It won't matter if you draw 2 balls at once or if you draw 1 by 1. So first and then second. The probabilities are still the same. Okay, which is kind of interesting. Right? Well, in a lottery it's a different story, because in a lottery you have a replacement. So which means they got a first number, and then they can again get the same number to be the second number, right? I don't know whether in a bingo or something, I don't know. If you allow replacement, if you allow repetition, it's a different story. So if you say there'll be completely different problem. You say, draw the first ball, and I'll put it back, and what's the chance you're gonna have again draw the second ball? What's the chance? That's a different problem. You don't want to think about that. But I was just talking, take 2 balls out of hat. So when you choose the first ball, if you do 1 by 1, you choose the first ball, you're not putting it back. So now drawing a second ball is going to be one of the remaining 6 there. Okay, so that's one kind of problem. All right, that's all there is to it. This kind of problem you can have with all sorts of different selections when you have 2 different types. You can have even 3 different types. You can have black balls too. That would be a more interesting problem. And but the thinking is the same. You can either calculate by using the combinations, you can calculate by using permutations, you can even calculate by using properties of probability. Pay attention to that, because it matters whether you use a combination or permutation, right? When we're talking about the seating in the van, we could not use the combinations there, because seating arrangement is a permutation, not a combination. So there's no way to use combinations there, so you have to use permutations there. But sometimes it doesn't matter, right? Like in here. So you can have a drawing of 1 by 1, or you can have a drawing of 2 at once, in which case the order would not matter to you. When you draw 1 by 1, the order matters. Okay? Alright, so that's my story. For those are all of the interesting problems that we have in this lecture, and we're gonna move on.